Hello, welcome back to my class. Today we're going to talk about system of equations. So here is an example. A small business produces soap and lotion gift basket. Neighbor, utility, and other fixed expense cost $6,000 a month. This is going to be our fixed cost. Each basket costs $8 to produce and sell for the $20 per basket. So how many baskets does the company need to sell each month to break even? So what is break even? So break even is when the total cost equals to the revenue, right? So that means we're going to have a two function in here. One is the total cost function. If we let n be the number of baskets that the company sells. So what will be the cost if we try to sell n basket? So the cost is going to equals to the fixed cost. That means even though you don't produce anything, you still need to cost you $6,000 for. You still need to pay for neighbors. You run the factory, such as utility, property tax, such things, and then also various costs. That means each basket, such as the material that you use to produce the basket, A times N. So for revenue, it's equals to what? So each basket you sell for $20, and then you totally have an N basket. So the total revenue would be 20N. So now given these two linear equation, to find the break-even point, we're looking for the number of basket where the revenue will equal to the cost, right? In other words, if we were to graph the two linear functions, we're looking for the points that lies on both sides. The solution is the point that satisfies on both lines. That means the intersection point. So to graph it, you can either graph it on your graph paper, but if you want to get a more accurate result, I would suggest you use a graphic calculator. If you don't have one, that's okay. You can use an online one. Now I'm going to show you how to do this. Okay, so Decimal is the online graphing calculator that Decimal that I use. So on the top, you will see a math tools. Click on here, the drop down menu, they have a graphing calculator. And then you type in the two functions that you need. The cost equals to 6,000 plus 8N. And then the revenue equals to 20N. Okay, so you see the red represent the cost function, and the blue line is going to represent the revenue function. Of course, you can also change the color here. Okay, so why I don't see the red line, I only see the blue line? Well, because we haven't set up the range yet. Remember, what will be the y-intercept point? So when n equals to 0, c equals 6,000. But here, the range, what we can see is to 40 something, right? So to change it, there on the right top hand side, there is a graphing setting tool, and now we can set up. So y-axis, does it make sense if we produce negative number of basket? This will make no sense, right? So we will set this as 0. Or if you want to see a little bit, you can set it as 10. But in here, since our cost at least is 6,000, we want to set it a bigger number, maybe 500, 5,500, something. Okay, so, or maybe something even bigger, like 800 or 8,000. Okay, so for y-axis, we can start in with negative 14, negative 10, that's okay. But on the top, we might want some number that bigger, since at least the cost is 6,000. We're looking for something, let's try 10,000. Oh, now we see the red line. Okay, have you seen the intersection point yet? No, so that means we need a bigger range. Let's do 15. Okay, so now we see the green line, the blue line and the red line. Okay, so now the intersection point is 500 and 10,000. That means what? If you click on here, you find the intersection point. That means the break-even point is hold on. Oops, sorry. Let me show this. Okay. So the break-even point is going to be what? When n equals to 500, the cost is equals to what? 10,000. Also, the revenue also equals to 10,000. So this is going to be the break-even point. So now let's see another examples. So in here, a company produces a basic and premium version of its product. The basic version requires 20 minutes of assembly and 15 minutes of painting. The premium version requires 30 minutes of assembly and 30 minutes of painting. If the company has staffing for 3,900 minutes of assembling and 3,300 minutes of painting each week. If the company wants to fully utilize all staffed hours, how many of each item should they be produced? So, in order to do this, first, this problem has two variables, right? One is the basic product, the basic version of the product that we want to produce. The other one is the number of the premium version of that product we want to produce. So in order to do that, usually it's easy how to set up the equation. Well, the easy way to do it is we make a table of it. So now we have a basic version of it and the premium's version of it, right? Okay, so for the basic version, we have what? The assembly and the painting. So for the basic version, it requires what? 20 minutes for sampling and 15 minutes of painting, right? For the premium one, it requires 30 minutes to assembling and 30 minutes for painting. And then the company has the staffing for what will be the total. So the total number of assembling is what? 3,900 minutes. And the total number of painting is 3,300. So we don't know each number, right? So let's say if we let X be the number of the basic version product the company produce, and then Y be the number of the premium version products that the company produced and make. So now we will have what? This is going to be our X, this is going to be our Y. So how do you calculate the total time of assembling? So if we totally have X basic products, so that means the assembling time for the basic product would be what? 20x, right? And then the total assembling time for the premium product would be 13x. Does this make sense? Oh, I'm sorry, not 13x, because we have Y products, so it should be 13y. Okay, so the total assembly time should be what? The total basic product time that takes for you to assembling plus the total assembling time for the premium product. So that means 3,900 equals to 20x plus 13y. Okay, for painting, we know that the total time is what? 3,300. And then that requires two parts. The total time that you spend on the basic product, which is 15x. And then the other part is the total time that you spend on the premium product, which is 13y. Okay, so now we have these two equations. So how do we find the solution? Well, we are trying to find how to fully utilize all steps for the hour. So that means we are trying to find out the intersection point, right? To solve an equation, we want to solve the intersection point. Again, you can calculate it by hand. So now let's try to use a decimal that we used earlier and see how do we do that. Okay. So for decimal, we have what? 29. One is 39 equals to 20x plus 13y. And then we have 13.3 equals to 15x plus 13y. So now we're supposed to see a green line and blue line. If you don't see it, that means you didn't set up the range right. We can by zoom in to find out, hey, what will be the intersection point. Okay. So the intersection point would be here. You can see it. So that means when x equals to 120, y equals to 50, the complaint is going to be fully utilized the staff minute. So we find out that x equals to 120, y equals to 50. So how if during the quiz or test you're not allowed to use a GeoGebra or decimal, any of graphing calculator or scientific calculator too, how would you solve it? Well, we learned this before in high school probably, or in Math 19.7, I believe. So you have two equations. You can either use substitution or elimination. So let's assume that we can use a graphic calculator. How do we solve it? You have two equations, 1 and 2, since they both have 13y and 13y. We can use elimination. That one would be easier than substitution. We can use the first equation, subtract the second equation. So the left side subtract the left side and the right side subtract the right side. So we have what? 3,900 subtract 13,300. We have 600 equals to 20x subtract 5x with 5x left. And then 13y subtract 13y, we have 0. So you divide it by 5 on both sides. We solve for x. So we solve for x equals to 120, which is what we found from the decimal graphing. And then after we find out x, we still need to solve for y. Well, we substitute x equals to 120 either into the first equation or the second equation. Either one works. So in this one, I'm going to substitute into the second equation. So we've got 3,000 equals to 1,800 plus 13y, and then we subtract 1,800 on both sides, so we get rid of 1,800. So this is equals to 1,500 equals to 13y, and then we divide by 13 on both sides. We have y equals to 50, which is what we got from the decimal. Okay. So we still need to answer the solution by, okay, if, in the sentences, if the company wants to fully utilize all staff hours, so how many of each item should they produce? So x equals to 120. Remember when we set up x is what? The number of the basic version product. So that means the company needs to make or produce 120 basic version of the product and 15 premium version of the product. So in the previous two examples, I show you how to use a two linear equation, which is, we call it system of linear equation, to solve the real world problem. So, however, there could be a trick. Sometimes, not every systems of equation will exactly have one solution, but we will look more closely at this and to check if an order pair is a solution to the system equation. There's two things you could do. Either you can substitute the order pair into each equation into the system, and then to determine if that's a true statement result from the substitution in both equations. If so, the order pair is the solution. The second thing to do is use our graphing calculator. You can use an online one, or if you have a scientific calculator, you can also use that one to see if the intersection point is the order pair that you're looking for. So here is an example to determine whether the order pair 5 and 1 is the solution to the given system of equation. To do that, we can substitute the order pair, right? Use our first method. Again, you can use a graphic calculator to check that. So now let's substitute 5 and 1 into both equations. So to substitute into the 1, we have what? X equals to 5, and then plus 3 times 1. Is this equals to 8? Yes, this is equal to 8. So that means the order pair satisfies for the first equation. Now let's substitute into the second equation. 2 times 5 minus 9, do they equals to y, which is 1? We don't know, that's why we have a question mark. 2 times 5 equals to 10, 10 minus 9 equals to 1, 1 equals to 1, yes. So that means the order pair, they both satisfy the given system of equation. That means the order pair is the solution. So in the early example, when we're talking about doing the SOAP, I mentioned that there's two ways to solve a linear equation. One is elimination, the other one is substitution. Oh, actually 3. The third one is using the graphing calculator. So if we just calculate by hand, we have 2 methods. So I want to go over the 2 methods in here today. So, for example, if I given you a system of linear equation, which is negative x plus 5 equals to negative 5, 2x minus 5y equals to 1. This system of equation, and I want you to solve it by substitution. What do? This is equal to negative 5. So usually my first step is I would want to label the equation 1 and 2. So from number 1, if I want to substitute maybe y into the second equation, so from the first equation, I have negative x plus y equals to negative 5. So you can move x on the right side of the equation, right? So from 1, I have that. But I want to solve for y because I want to substitute y into the second equation. So that means I want to add x on both sides. So I have a y equals to x minus 5. And then after I got that, I can write x minus 5 equals y. And then I want to substitute y equals to x minus 5 into the second equation. So I have a 2 times x minus 5 times x minus 5 equals to 1. Now let's solve for x. So first I have 2x, and now I distribute negative 5, and remember it's negative 5, not just 5, into the equation. I have negative 5x, and then negative 5 times negative 5, I have positive 25. Be careful about the sign. And then I have what? Negative 3x plus 25 equals to 1. And then I subtract 25 on both sides. So I have a negative 3x equals to negative 24. And then divided by negative 3 on both sides. So I have x equals to 8. So after we solve x, I can substitute x equals to 8 into either the first equation and second one. Which one would you choose? I would choose 1 because it looks easier, right? So I have a negative 8 plus y equals to negative 5. And I add 8 on both sides. So I have y equals to 3. So that means our solution is what? X equals to 8, y equals to 3. So another method is elimination, which I showed you earlier for the second example that we have. Now let me give you another example. What if you have something like 2x minus 7y equals to 2, 3x plus 7y equals to negative 20. I want you to solve the system by elimination. Okay, so if you look at this, you can notice that the coefficient is different. One is 2x, the other is 3x. One is negative 7y, the other is positive y. So how do you do that? Well, you try to make them the same, otherwise you will not be able to eliminate them by adding or subtracting, right? So which one you want to eliminate, x or y? It seems y is easier because x, 2x, and 3x is hard to make them the same unless you multiply a fraction. But for y is, for the second equation, you can multiply 7. So then you're trying to get 7y, right? If you times 7 to the whole second equation, what do you have? You times 7, you need to multiply 7 to every element for the second equation. I have 21x plus 7y equals to negative 140. Because you need to, again, multiply 7 for every element. So now let me rewrite the equation. So now I have a 21x plus 7y equals to negative 140. And then the first equation is 2x minus 7y equals to 2. This is our second one. This is our transformed second one. I can call it 2.1 if that's easier, because they already transform into the form that is easier for us to eliminate. So I have a 7y and negative y. How do I eliminate y? We can add both, right? Because 7 at negative 7, we will have what? 0. So that means I want to use the second equation on the first equation. I want them to add. So the 21x add 2x, 23x. 7y at negative 7y equals to 0. Negative 140 at 2, I have a negative 138. So now divided by 23. X equals to 6. After I solve for x, I need to substitute x equals to 6 into either the first equation or the second equation, or even the transformed second equation. Which one would you choose? I would choose either the second one or first one because that looks easier, especially the second one. So I'm going to substitute that into the second equation. So I have 3 times 6 plus y equals to negative 20. And 3 times 6 equals to 18 plus y equals to negative 20. I subtract 18 on both sides. So y equals to negative 38. Okay, so next part of this chapter. So in the previous lectures we discussed about the graph of a linear equation. They have several forms. One is, let me draw it. One is going to have one intersection, right? Like this. They will have one intersection in here. So another form would be what? They're parallel. That means what? If they're parallel means how many intersections do they have? They will have no intersection. That's parallel. And then the third one would be what? They are totally overlap. So these two lines, they overlap. That means they have infinite many solutions. So for the first one, we call this is independent system. So independent system means has exactly one solution pair, which is in here, x and y. The point where two lines intersect is the only one solution. So the second one is called inconsistent system. Consistent. Yeah, I spelled it right. Inconsistent system means has no solution. Because notice that two lines are parallel, that means they will never overlap, or they will never intersect. If there's no intercept, that means there's no solution. So the last one is called dependent system. So dependent system has infinite many solutions. The lines are coincident. They are the same line, so every coordinate pair on the line is the solution to both equations. So let me write this again. So for independent system, they have one solution. For inconsistent system, they have zero solution, means no solutions. And then for for dependent system, they have infinitely many solutions because everything they overlap. So let me show you an example. Okay, let's solve the following system equation. We have x equals to 9 minus 2y and x equals to y equals to 23. Try to solve it without using the graphing calculator and see what do we get. Okay, so x equals to 9 minus 2y. X plus 2y equals to 13. Okay, so in this one, I would use either substitution or addition. It looks like I will use substitution because one is easier. Already give you the, hey, x equals to 9 minus 2y. I can just substitute x equals to 9 minus 2y into the second equation. So I have a 9 minus 2y plus 2y equals to 13. 2y cancel out. So I have a 9 equals to 13. Is this true? Can 9 equal to 13? No. So clearly the statement is contradiction, right? This is a false statement or contradict. This is a contradiction because they are not equal. So therefore the system has no solution. And if they don't have a solution, this system is called what? Inconsistent system. So here is another example. So find the solution to the system of equation using the addition method. Well, addition method means elimination method. There's a specific mention which method you want to use. So I have x plus 3y equals to 2 or 3x plus 9y equals to 6. So we have 3x and x. And then in order to make them equal, we need to times 3 to the first equation, right? So that I can get 3x or 9y. So the first equation, we times 3, we will have our new transformed equation, which is 3x plus 9y, and 2 times 3, we have 6. So now this is a new equation. We write it with the second equation. So now use elimination. You can use 1.1 subtract 2 or use 2 subtract 1, either one. So when they're subtracting, 3x minus 3x equals to 0. 9y plus 9y equals to 0. Minus 9y. 6 minus 6 equals to 0. So 0 always equals to 0. So this is a true statement. So that means this is going to have an infinite many solution that satisfy both equations. In these cases, we can say this is what? A dependent system. Okay, so the last part of this chapter, I want to talk about how to solve a linear system of 3 equations. We have been trying lots of examples about 2 equations. The easier way to do it is to use a graphic calculator, but if you cannot using a graphic calculator, what would you do? Well, here is the steps. You're going to pick any pair of the equation and solve for one variable. You're trying to solve for one variable first. And then you substitute that solved variable into the other 2 equation. Then you will have what? A linear equation of a linear system of 2 equations, right? And then you just solve it like solve the system of 2 linear equations. Okay, I am going to show you an example how to do it. And then the last step is what? You still need to substitute the solved 2 variable, trying to find out one of the first variable, the solution for the variable. So that means you need to go back and substitute. So let me show you an example. So if I have x plus y plus z equals to 2, 6x plus 6x minus 4y plus 5z equals to 31, and then 5x plus 2y plus 2z equals to 13. So here is our system of 3 linear equations, right? Remember, our first step is we're trying to solve one variable and substitute it into the other 2 equations. Okay, let's use the first one because the first one is easier one. You can try to solve x first or y or z first, either one. So I want to solve z first. So from the first equation, we have x plus y plus z equals to 2. I solve for z. That means I need to subtract x and subtract y on both sides. So I will have z equals to negative x minus, 2 minus x minus y. Okay, after I solve for y, I need to substitute y into the second and the third equation. So that means we will have a transform second equation, which gives you what? 6x minus 4y plus 5 times z equals to 2 minus x minus y equals to 31. And then the transform third equation equals to 5x plus 2y plus 2 times 2 minus x minus y equals to 13. Okay, let's simplify it to make it easier for us to calculate later. So I have what? 6x minus 4y plus 10 minus 5x minus 5y equals to 31. And then we merge the like terms and move all the numbers to the left. So I have what? 6x minus 5x, I have x, negative 4y minus 5y, I have a negative 9y, subtract 10 on both sides, I have 21. That is come from our transformed equation, right? And here we do the same thing. 5x plus 2y plus distribute 2 inside the parenthesis, 4 negative 2x negative 2y equal to 13. Again, merge the like terms. 5x subtract 3x, 5x subtract 2x, I have 3x. And then 2y minus 2y, ooh, you have 0, which is nice. 0y. And then subtract 4 on both sides, I have 9. So now I have 3x equals to 9. Well, we already solved for x, right? Let me rewrite this. 3x equals to 9. Okay, so now we can treat it as a what? 2 linear equation. So we have our 3.2, 2.2, because we simplify it. I'm going to rename it, but they actually come from the same second equation. So that's why I keep it 2.2 and 3.2. So from 3.2, we have what? 3x equals to 9. So if we divide it by 3 on both sides, we have x equal to 3. And then we substitute x equals to 3 into the second equation. We will solve for y. We have 3 minus 9y equals to 21. So our y equals to negative 2. Okay, but we're not done. We solve x and y. We still have z, right? X equals to 3, y equals to negative 2. But remember, our z is equal to 2 minus x minus y. So I have z equals to 2 minus x minus y. So z is equal to 2 minus 3 plus 2. So z is equal to, So this is equals to 1. So that means our solution to this 3 linear system equation, or systems of 3 linear equation, equals to what? X equals to 3, y equals to -2, z equals to 1. So that's it for today's lesson. Let me know if you have other questions. See you next time.